This is tutorial 7, question 3. And in this question we have a dynamometer. It has the following dimensional specifications. The disc diameter is 250 millimeters, the shaft diameter 50 millimeters, the disc thickness is 10 millimeters, the clearance on the sides and along the edges is 1.5 millimeters. The fluid is an SAE 30 at 38 degrees. The kinematic viscosity is given, as well as specific gravity. We're given a formula that is used to calculate the rotational speed of the dynamometer. We're also given the stress allowable on the material and the density of steel. So the first question is calculate the maximum rotational speed of the dynamometer in revolutions per minute. Alright, using the formula that's given to us, we have omega times 3 times 320 times 10 to the 6, and that would be our stress in the material. 4 is the safety factor, and the stress allowable in the steel is 7,900, and we multiply that by the radii. 0,125 minus 0,025. We divide that by 0,125 cubed minus 0,025 cubed. That is all square rooted. And that gives us an angular velocity of 2.19 radians per second. We know that omega is 2 pi n over 60. Therefore, n is equal to 2.19 times 60 over 2 pi, or 11957 revolutions per minute. Alright, so that is the first question. Secondly, the total torque per disc at the maximum rotational speed. Total torque per disc at max speed, which we have just calculated. So our total torque equals torque on radially plus the torque on the sides. So if we had to draw a diagram, we have our shaft, and that has a disc on it. Around that we have the dynamometer housing. And torque on the sides would be there and there. The radial torque would be over here on top. Right, so radial torque is nu v over t times 2 pi r times L times R. So radial torque then substituting, we got 1,1 times 10 to the minus 4 times 880 times 12, 5, 2,19 times pi times 2 times 0,01 times 0,125 cubed, all divided by 0,0015. Radial torque works out to be 9,916 Newton meters. Alright, on the sides, torque on the sides is 2 times nu times rho density omega 2 pi over t times the integral of r cubed dr between r1 and r2. That equals 2 nu rho omega 2 pi over 40 r to the 4 between r1 and r2 after integration. So substituting, remember there are two sides, that's why we multiplied it by 2 times 1,1 times 10 to the minus 4, and that's 880 times 1252,12 times 2 pi over 4 times 0,0015 times 0,125 to the 4 minus 0,025 to the 4. So the torque on the sides equal to 61,876 Newton meters. So total is 9,916 plus 61,876 or 71,79 Newton meters. Alright, final question. The total power rating of the dynamometer fitted with 5 discs if the torque to overcome bearing and seal friction equals 0,4 Newton meters. So we've calculated for 1 disc, and now we want to know the total power for 5 discs. Right. So your power is the torque times omega, which is your angular velocity. So total power is equal to 5 times 5 discs times 71,79 times 12 plus, actually, it's plus 1252 19 plus 0.4 times 1252. Or 9. Oh, that is a multiply. So here we get 4,49473 watts plus 500,876. That's 449,973,876 watts. So that is the total power rating with 5 discs. That's how much power can be transmitted through the fluid coupling. And that's the end of this question.